Hello guys, today we are gonna create a solar monitor system using a Arduino based microcontroller and then transmit those values to our mobile device using the Blynk platform. Here to monitor the values of the solar panel we have used the INA219 board. We can use this board to monitor the voltage and the ampere ratings. Here in WemosD1 Mini, it is ESP8266. In the INA219 board, we can see a shunt resistor. The maximum current that can be measured from this board is 3.2 amps. So if we want to measure a higher value, we have to change this shunt. And we have to make sure that we do not exceed 320 millivolts after calculating V equals IR. Then we can add a corresponding shunt resistor and then edit the libraries of the Arduino IDE to the matching resistor values. Here we have used a relay to control the garden lights. The relay is controlled by a transistor and an optocoupler, and a diode is used to eliminate the back EMF from the relay. Make sure you use a diode and an optocoupler, otherwise the pin of the microcontroller will be damaged. Let's see how the SCL and SDA wires are added to the microcontroller. This is the wiring diagram between the INA219 and this microcontroller. Please use the chapters from the description to engage in the programming part of the Arduino IDE.
if I want some peace or if I want the glory. Yeah, don't want a life that is complacent or possibly boring. I just want a life that is worth every day exploring.
My whole life I just wanted someone who would notice me. My whole life I just wanted to be somebody to be. Yeah, I just wanna be great. 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 Yeah, I just wanna be great.
This is a statement to appreciate all that is vacant. It's just for the taking. If you make up your mind, you can take it. I'm never complacent. I would work in a mansion or basement. Yeah, there's no replacement for persistence. It's a patience. Yeah, in this life, I wanna be soaring, to feel sun inside when it's pouring.
Alright, to start the programming, first open the Arduino IDE. Then go to Files and then Preferences. Here you can see a link in the description. Please copy that link and paste it in this box. After that, go to Tools, then Board and then Board Manager. Search for ESP8266 and install the board. After installing the board, again go to Tools, then Manage Libraries and install these 4 libraries to Arduino IDE. This ESP8266 IDE is used to connect with Wi-Fi, and Blynk is for the Blynk platform, and INA219 is for that measuring board. Here we can see one wire. This is for the I2C connection. After installing all the libraries, go to Tools and select your board. Here I am using a WemosD1 Mini. So after selecting that board, I am going to select the port. Here this port is the USB port where your microcontroller is connected to your computer, and if that's not located in there, you can search the port in Device Manager and make sure you have installed the correct drivers for that chip. After selecting the board and the port, we can see the Blynk authentication code and the Wi-Fi SSID and the password. Here for this authentication code, we have to create our Blynk platform and start a new project. Okay, let's start a new project. To start a new project, I am stopping the current process and go to a new project. Here, as the first step, we have to enter a name and then the board we are using the Blynk with. After that, select Wi-Fi. The authentication from the project is already sent to our email. This is the authentication code that we have to enter in the Arduino IDE. Here we can see all the buttons that we can add to our project. After adding a button, we have to name our button. Then we have to select the digital or a virtual frame from our board. Here I have used the digital pin to control the garden lights from the relay. I have connected the relay to the D1 pin, so I have selected that pin from the Blynk app. After setting that, we can play our project. Here you can see the relay is working according to my button click. Let's test the readings with the Blynk app. Here you can see the input voltage from the right pin of the INA219 board, and it's reading 12 volts. And this is the previously mentioned D5 pin with the relay. I have wired the 12 volt LED, and after connecting the LED we can see a 36 milliampere hours reading. And we can see the power readings and watt-hour readings from our calculations in the code. Here I have connected the 5 volt input line, and let's flow a UV bulb from the 5 volt line. After connecting the LED, here you can see a 5 volt input line and 124 milliampere reading. and here you can see the power reading as well. And again, let's input a 3.3 voltage line from the microcontroller and measure that voltage. To measure the voltage, we have to create a common ground. And that's it guys. Please subscribe and give a like to my video. Thank you very much.